Hi everyone. Today I'd like to introduce our strategy at the BioCreative 7 Drug Plot Challenge. We are a team from Korea University and AstraZeneca. Our title of our paper is Using Knowledge Base to Refine Data Augmentation for Biomedical Relation Extraction. My name is Wonjin Yoon from Korea University. So here's our motivation. Building a biomedical NLP datasets are expensive. So it is difficult to build a high quality and also large scale bioNLP datasets. So utilizing unlabeled data can be one solution for that problem, as it enables model to learn from large scale data. So existing method can be a self-supervised learning, and another branch can be a data augmentation method. Specifically, we can use knowledge base to generate a distantly supervised dataset, and also we could weakly label the dataset by using model generated labels to and augment the existing dataset. So for self-supervised learning in other words, we can use a pre-trained language model like bot, biobot, or some robot or other transformer models. And the other branch, data augmentation, we could use distantly supervised dataset or model generated labels to augment the existing dataset, but both methods add noise to the augmented dataset. I will explain more in the following slide. But what I focused on is that the noises comes from different nature. So noise from two methods are originated from different reasons. So let's take a look at the first method, the noise from distant supervision. There might be a various reason for the noises, but the first thing come to my mind is that it comes from incomplete information in knowledge base. For example, a sample or sentence with relation can be labeled as negative if the relation is not listed in the knowledge base. Or for the other reason, the simple matching can be accrued. Just simply matching two entities inside in the sentences that can produce error, as the sentence can be a semantically irrelevant sentence. The entities might have be just simply listed in the sentence. In other words, a sentence will be labeled as positive example if two entities exist in the same sentence, even if the sentence does not have any clue of relations. Let's take a look at the second method, that the noise comes from weakly labeled dataset. The labeling noise in the original dataset that used to train the model that generate the label, that in the noise inherited to the generated dataset. And also the another reason is that, and also model performs poorly for some novel data points, data samples. And as an example, the model may produce wrong label if the input sequence is not from the distribution of training datasets. Simply we can call it as unseen test samples, and we think that model will perform poorly for those unseen samples. So here's the thing, that by exclusively using the two augmented data, in other words, there should be an agreement to use the augmented data point. So we could reduce noise in the weak label by filtering long samples with knowledge base. Let's take a look at this figure that for the previous two methods, the size of noise was relatively large, like this entire circle or the circle on the right hand. But if we use a trained model to generate the label, the first step would be a weakly supervised dataset, and we filter out that we check validity of predicted labels with knowledge base. Then we could possibly reduce the noise into this small portion of the data. So we drop generated data samples that does not agree with knowledge base. So here's the method. We built a pipeline approach for building a large-scale augmented dataset. As you can see here, we use drug-prot dataset to train language model to make a drug-prot model, and we use that model to generate the augmented dataset. We inference Medline corpus with that model to make a predicted label, and also filter out the predicted label with knowledge base, and we finally generate augmented dataset. We use the sequence classification model. We use output of the Sierra's token for classification head, and we use a one layer linear layer, and we did not anonymize the entities and use entity marker. Also, we use sentence level input. We split sentences using Stanja, and we use BioRM by researchers at Facebook and also UCL. And the model is based on robot large, but trained on pre-trained on biomedical corpus. And for other settings, maybe this can be a most important thing for the performance, but we use ensemble method for and we trained 10 or 5, depends on the settings, with different random seed, and we used ensemble models method for main track only, and we also utilized training and development dataset for training. So we merged training and development dataset into 10 particles, and we used 9 particles for train and 1 particle for dev, and we did it for like 10 iteration, like we did for 10 cross-validation method, and we ensembled those 10 models. So this is the result when we check the results with development dataset. We constantly observe that we could gain about 1 point F1 across various settings, like different language models, including BioBot, PubMedBot, and BioRM. And we measured that performance using average score of 10 independent run. Also, it was measured without ensemble method. But for when we check out the data, test data, the performance was a little bit inconstant with the development dataset. But we could observe that this augmented data method gets constant gain in recall. You can see the red box set here. And also for different settings, we would like to mention that the different settings in ensemble was applied for this augmented dataset and non-augmented datasets. So I think that might be one reason for we are suspecting, but one reason for inconsistent results at the test time, that we only used 5 models for augmented dataset. And the final one, using train and dev dataset for training, was very effective. That showed it was not very bad. It showed about 0.3 performance gain. And also we suspect errors in pre-processing step for the large track, as the performance was not nice as expected. So we will take a look at that aspect. And we have another interesting analysis on the self type of relations, but unfortunately we does not have enough time to introduce that aspect. So please, if you are interested, please visit our paper to take a look at the one. Thank you very much, and please contact me for further discussion on the matter. Thank you.